These propellers look similar, but the truth is they each behave completely differently, and one test really surprised me. So what actually changed between these two designs? This one has a slight S-shaped curve that runs through the blade, while this design is almost completely flat. Looking at them, I assumed the curved blade would perform better, because the curved shape, in theory, should move more air. But that's not exactly what happened. That's over a second faster, just from changing the blade shape. So I wanted to understand why. First, I need to make sure this was actually a fair test. The motor stayed the same, the board stayed the same, and the weight didn't change. The only thing that changed between tests was the prop design, but for each design, I used the same material and print settings. So if blade shape was responsible, what about blade count? So I took the same curved design and I removed one blade. In theory, fewer blades should reduce drag. The two-bladed curve prop took 3.81 seconds, while the three-bladed curve prop took 4.38 seconds. So removing a blade clearly helped, but that still doesn't explain why the flat blade was so much faster. So instead of removing blades, I added slightly more curve. That dropped it all the way down to 3.80 seconds, almost identical to the two-bladed design, but still not beating the flat blade at 3.03 seconds. So what does this all mean? I'm not entirely sure, but when you line them up like this, something stands out. The flatter the blade got, the faster the board moved, which is kinda opposite of what I expected to happen. My original assumption was that more curve would move more air. But what if that extra curve is actually creating more drag, forcing the motor to work harder? Because this motor can only produce so much torque, once you exceed that, the RPM drops. And if RPM drops, speed drops. Which is exactly what we saw happen with the original curved blade. The flatter design didn't ask as much from the motor, so it kept its speed. And here's something I almost missed. The more aggressive three-bladed design actually matched and technically beat the two-bladed version. So it's not just about removing blades. Originally I thought blade count might be the dominant factor, but increasing pitch gave almost the same improvements, which suggests that drag and RPM might matter more than blade count alone. So removing a blade helped, increasing pitch helped, but neither was enough to beat the flat blade. And there was something else I noticed. The two-bladed prop actually sounds slightly deeper, while the more aggressive three-bladed prop sounds a little higher. That usually means they're each spinning at a different RPM, but there's also another possibility. These blades are only 3D printed, and they're only 0.03 inches thick. And at high RPM, thin plastic doesn't stay perfectly rigid. It bends. You can actually see the blade start to flex when the RPM increases. But it's not the same across all the designs. And that's probably not helping. What's interesting is the more aggressive curve actually bends the least. The original curved blade and the flat blade flex more noticeably. So stiffness alone doesn't explain the results. The aggressive curve was more rigid, but it still wasn't as fast as the flat blade. So at this point, there are a few things happening at once. Blade count clearly changed the results. Increasing pitch clearly changed the results. Motor torque limit clearly changed the results. And even how much the blade flexes can change the results. But there is still something important to keep in mind. All I measured was the time. I didn't measure the thrust directly, I didn't measure the RPM, and I didn't measure the current draw of the motor during each test. So, if the flat blade was the fastest, why? It's not the most rigid, it's not the most aggressive, and it's not the lightest. So the advantage probably comes down to how efficient it is with the motor. And what's interesting is this result might completely flip with a more powerful motor. If torque wasn't a factor, the more aggressive pitch may have had a shot. So it's not just about the blade design. It's about what the motor can actually handle. Which means the best prop really depends on what you're spinning it with. Because a prop that's too aggressive for the motor just ends up slowing everything down. And honestly, that wasn't what I expected. I assumed the curved blade would perform better, but in reality it just created more drag on the motor. The simplest design ended up being the fastest. Not only because it creates less drag, but it also fits the motor better. Good to know.